A particle is moving towards a concave mirror, r is the radius of curvature, from a large distance. Speed of the image formed by the mirror as a function of distance x of the object from mirror is. Basically, suppose here it is our concave mirror and this is its principal axis and some object is approaching towards the concave mirror from a large distance with a constant speed v, and assume that at a certain instant of time let x be the separation between the object and the mirror as it is specified here, that we have to find the speed of the image as a function of distance x, which is the distance between object and mirror. So here we can first use the lens mirror formula, which is 1 by f is equal to 1 by v plus 1 by u. Here v is the image distance. Since it is a concave mirror, so focal length has to be negative, so 1 upon f is minus r divided by 2, because radius of curvature here is specified, is equal to 1 by v plus 1 by u. U is minus x. That means we can rearrange this equation as 1 by v is equal to 1 by x minus 2 divided by r, which means if we take rx as LCM, then what we'll get is r minus 2x here. Okay, so 1 upon v is r minus 2x upon rx. That means image distance as a function of the object distance is given as r times x divided by r minus 2x. This is the image distance from the mirror. So we can differentiate this distance with respect to the time to get what? The image speed. So speed of image can be calculated by differentiating v. So dv by dt is our answer basically. So here we can see that it is a function of x, so we can always differentiate this in terms of x, and then later we can differentiate x in terms of time. So let us first differentiate this with respect to x. So we can apply here the division formula of differentiation. So what it becomes, first we put square of the denominator and then put denominator without change as it is, and then differentiate the numerator. So here rx, if we differentiate it with respect to x, we are going to get r, and then minus numerator into differentiation of the denominator. So differentiation of the denominator, r is constant, so it is going to be 0, and here it is x, so minus 2 x differential is 1, and outside we'll write dx by dt. Okay, because we are ultimately differentiating it with respect to the time. So now we can rearrange this equation to get the value of dv by dt equal to what would be, it will be r minus 2x whole square, and in numerator you can see here that it is r square and this is minus 2xr, and here it is plus 2xr, so both gets cancelled. So here it is only r square. Okay, r square, and further here is dx divided by dt. So now what is the value of the dx by dt? Dx by dt is basically the speed of the object. If we write it mathematically, then dx by dt will be written as minus v, but we are just talking about the magnitude dx by dt. So the magnitude of the image velocity anyway is going to be r square into, here it is r minus 2x whole square, and dx by dt magnitude is v. So this is the speed of the image. So option A will be the correct option to this question. It doesn't matter it is r minus 2x or 2x minus r, because it is inside the whole square. So option A is the correct option to this question.